Hi everyone, my name is Wesley. With my co-author Manish, we're here to present our work exploring how machine learning practitioners try to use fairness toolkits. This work is done with our amazing collaborators, Michelle and Jad from University of Cambridge, Stephen, Ken, and Haiyi from Carnegie Mellon University. Recent years have seen the development of many open source machine learning fairness toolkits intended to assist ML practitioners in assessing and addressing fairness in the ML systems they develop. For instance, companies such as Microsoft, Google, and IBM, and research institutes like U Chicago have published combinations of toolkits and guidelines that incorporate fairness as part of their core values. However, despite growth in the development and dissemination of fairness toolkits, there has been little research investigating how ML practitioners actually use these toolkits. In order to explore practitioners' perceptions and desires around open source fairness toolkits, our collaborators, Michelle and Jad, conducted an interview study to begin to understand practitioners' perceptions of current fairness toolkits' strengths and weaknesses. In a similar vein, Richardson et al. Conducted an interview study in which participants were asked to evaluate the analysis done by researchers in order to generate a practitioner-oriented rubric for evaluating fair ML toolkits. These two studies both offer extremely valuable insights regarding the usability and design of ML fairness toolkits. However, neither of these two works engaged practitioners directly in using the fairness toolkits within the context of a real ML task. Now you might ask, why do we need to directly engage practitioners in using ML fairness toolkits in real tasks? A long line of prior research in human-computer interaction has emphasized that in order to understand the usefulness and usability of any type of software toolkit, it is critical to observe how practitioners actually use them to perform real-world tasks. Simply asking people how they think they would use the toolkits often gives a misleading picture. Motivated by the gaps in prior literature and current ML fairness practice, in this study, we try to answer two research questions. First, how do practitioners try to work with existing ML fairness toolkits? Second, what opportunities exist for fairness toolkits to better support practitioners during different phases of machine learning pipelines? To answer these two questions, we first conduct a think aloud interview study with 11 industry practitioners to understand how they actually learn about and use ML fairness toolkits. We then conducted an online survey of industry practitioners to better understand the real-life drivers and obstacles to using fairness toolkits, and also to supplement the interview findings with larger sample size. I'll start introducing the Think Aloud interview study. In order to immerse the practitioners in a realistic ML life cycle, starting from exploratory data analysis and problem formulation, we first have our participants conduct a preliminary task before entering the main Think Aloud study. In the preliminary task, we first ask our participants to conduct an EDA on student performance dataset. These datasets concern with academic achievement in Portuguese secondary education schools. Attributes include student grades, as well as students and their families members, demographic, social, and school-related features. We then ask our participants to formulate an ML problem and train an ML model to determine which students were in need of additional tutoring resources and help the school to allocate their limited tutor resource. Feel free to scan the QR code to view our task design in details on a public Colab notebook. Participants then enter the Think Out Loud interview study that took roughly an hour. They spent the first 30 minutes to explore FairLearn and AF 360, two most useful and well-documented current fairness toolkits surfaced by Michelle and Jess' prior work. After exploring the API of both toolkits, participants picked one toolkit and used it to assess and mitigate potential biases exhibited in the ML model they built in the preliminary study. Importantly, as participants traverse through the API interfaces and implementing codes, we encourage participants to think aloud and discuss the various information that was being displayed and how their understanding of the task and ML fairness issue around the task were developing. Before beginning our study with industry practitioners, we first recruited 2 university computer science students and conducted a semi-structured interview as our pilot study to help us polish and iterate upon our study protocol. Overall, 41 industry practitioners responded to our recruitment message. In the end, 12 participants attended the interview study and 11 of them completed all phases of the study shown in the above table through P1 to P11. Participants self-reported on average 5 years of programming experience and 3 years of ML experiences. They also self-reported that they had previously encountered fairness issue in their professional work and had never used a fairness toolkit prior to join our study. All participants were compensated with a $50 Amazon gift card upon completion of the study. For our online anonymous survey, we developed a survey containing 3 main sections. First, background and information questions asking participants industry domain and relevant experience in ML, ML fairness toolkits. Second, questions about fairness toolkits themselves. And third, questions about using fairness and fairness in general in the practitioner's workplace. In total, we have 71 people who started the survey. 56 of the respondents completed at least one entire section, and 21 completed the entire survey. Please scan the QR code to view the complete survey statistics if you are interested. We present findings from our study divided into 3 main phases: preparing to evaluate fairness, exploring and learning about toolkits, and attempting to use toolkits. Now I'll hand over to Manish to present some of our findings and design implications.
Thanks, Wesley. Let's first start with our observations and design implications in the phase of preparing to evaluate fairness. We found that even starting the early stages of machine learning development lifecycle, such as exploratory data analysis and problem formulation, participants' analysis choices were heavily influenced by their personal experiences, knowledges, and beliefs. For example, when explaining their concerns about the father's job and mother's job's features, P5 mentioned it was less from the ML perspective, but more from my personal experience as a teacher before. If the parents have higher education, it gives some cognitive bias to the teacher. Interestingly, most, i.e. 7 out of 9 of the participants who assumed sex was a sensitive feature, attempted to mitigate biases in the ML pipeline by simply removing or ignoring the sensitive features like sex or address. This fairness trap was identified by Dwork et al. Called fairness through unawareness a decade ago. Although it's widely discussed in the fact community, surprisingly in our study, most practitioners still committed to this potential pitfall during their ML fairness practice. Some participants reformulated the ML problem to a format for which current fairness toolkits provide more support. Specifically, 5 out of 7 participants who had initially formulated regression problems during the pre-task phase decided to reformulate their problem as classification. For example, P4 switched to classification after realizing more comprehensive support for classification from both toolkits, adding that I would have just framed a classification problem if I knew in advance that the toolkit supports that more. An online survey participant stated it was hard to apply AIF 360 to many of our models which are not binary classification, e.g. for regression models, and there's not much guidance on if or how the toolkit should be used. In other words, the current support or limitation of fairness toolkits affected our participants' problem formulation. Based on these 3 observations, we offer the following design implications for future ML fairness toolkits. First, broaden the scope of fairness toolkits to across the ML development lifecycle, given that current fairness toolkits offer little support for the early stages of the ML development lifecycle, such as the EDA and problem formulation stages. To do so, we encourage incorporating interactive interfaces to help users explore datasets and discover potential biases, as well as also including instructions and educational materials on creating and reviewing context documents like datasheets and model cards. Second, given the pitfalls we observed in our empirical study, we argue for showing practitioners both patterns and anti-patterns, such as common pitfalls for toolkit use. More concretely, one possible design opportunity to help users avoid fairness traps, like fairness through unawareness, is to display contextual warning messages that target common sources of missteps. In many domains like medicine, aviation, and structural engineering, checklists are used to support task completion, guide decision-making, and prompt critical conversations among stakeholders. Inspired by this, we could also incorporate checklists to help practitioners avoid oversimplifying or forcing an ML problem formulation due to toolkits constraints. Now, I'm going to share observations from participants exploring and learning about toolkits. Through the exploring and learning phase of our study, we identified the above 4 major design requirements for fairness toolkits among participants. In this talk, I'm going to expand on the first design requirement we identified, using toolkits as educational tools. Instead of directly applying fairness toolkits to their current projects to address fairness issues, some participants were most interested in using toolkits to learn more about the ML fairness concepts and terminologies. For example, P2 mentioned that ML fairness is something new, not directly related to my work, and I just got into it maybe a few months ago. The most important thing for me is the explanation of metrics instead of the mitigation or code. Additionally, participants such as P10 above wanted to learn more about fairness, especially due to the current lack of resources to learn more about ML fairness in their companies. Our survey results further supported this finding. When we asked the above survey question, we saw that 39 participants, out of 39 participants, over 82% of them selected to learn more about ML fairness concepts and terminologies. 27 of them selected to learn more about the typical process of dealing with ML fairness. Thus, we offer the above design implications. First, support practitioner learning within fairness toolkits, as well as supporting practitioners in incorporating toolkits into their existing pipelines. Now, let's take a look at attempting to use the toolkits. Although current toolkits target individual developers, participants wanted to see more functionality to support collaboration among multiple diverse roles, including non-engineers. Participants found that visualizations, for example, dashboards, are much needed in order to explain fairness toolkits to non-engineering roles within an organization. As P9 states, from a business standpoint, the FairLearn dashboard is more helpful than Jupyter Notebook. Meaningful assessments are inherently contextual. Use-specific guidance is therefore important for helping practitioners place the toolkit's offerings within the broader context of concerns, while encouraging cross-functional collaborations where appropriate. Now, we would like to open for a broader discussion around the future of ML fairness toolkits. Our findings have shown that practitioners desire more support in contextualizing, communicating, and collaborating around ML fairness efforts throughout the ML development lifecycle. We also hope that our work will inspire future empirical evaluations of practitioners' use of fairness toolkits to empirically inform toolkit designs. Future work should aim to engage practitioners from more diverse regions, domains, and organizational contexts, given that practices and challenges may vary significantly across each of these dimensions. Please refer to our full paper for more nuanced discussion. Thank you.